So, thank you very much. It's a pleasure to be here. I love being at conferences that are not like mainstream America, and there's so much interest here in Europe. I am a recovering aerospace engineer for 20 years. I decided aircraft, I was never going to get wealthy. I thought I'd make more money in the internet. And then I shifted into video, and for 20 years I've been fascinated with all the different sides of video. I'm also from Zimbabwe, if you're wondering where the accent's from. So I'm very sympathetic to Simon's talk. Right? I grew up in that world, but I was lucky enough to be in column 4, and I'm very cognizant of that. And I think many of us, we think, oh, we got here, we work for tech companies because we worked harder than some person next to us. And it's true, everyone here worked hard, but at the end of the day, I think we're lucky. Other people work just as hard and they don't have what we have. So I'm giving a talk about 3 subjects that I'm actually quite passionate about now: QUIC, MOQ, and WebTransport, and we'll get into what they are. So firstly, WebTransport. WebTransport, as its name suggests, is a new transport for the web. It's essentially a protocol developed by the IETF. But the cool part about it is, while it can go to any operating system, we're developing an API in the browser so that you can access it from the browser today. I chair the working group that is implementing this in the browser. It gives you parallel streams of reliable and ordered data, right? So think of a WebSocket as reliable and ordered. WebSocket includes framing, though, which we don't include. We are just a pipe, a highly efficient pipe between a client and a server. It also gives you JavaScript access to datagrams. You can write individual datagrams with this API, and then you can do cool things with them, layer in your own FEC. So it's quite flexible for those in that world. A lot of people ask me, what are some benefits or differences with WebSockets? I am not here to say don't use WebSockets or don't use data channel in WebRTC. WebTransport is like another tool in your toolbox, right? You're building beautiful things. Here's another tool that maybe you can continue building with. So some differences between, you get no header line blocking between your streams in QUIC. You do get a header line blocking within a stream. You get very fast connection handshakes due to QUIC if you care about session establishment. There's connection migration on the fly. Flexible congestion control, that's a plus and a negative, depending which side of that argument you're on. You bring your own framing, right? There's no such notion as a message for WebTransport. You've got to write your own framing and direct datagram access. So we're hoping really to get the spec to go to the next step, candidate recommendation, by December of this year, and have it released. But it is available, well, let me just show you the tech stack. These are the tech stacks that we all work with today. WebTransport is essentially built on top of QUIC, which is built on top of UDP and an abstract layer called HTTP transport. There's also a parallel H2. This is for networks that for some reason block QUIC. Some do today. I don't think many will over the next few years, but if you want to make this robust, you need a failover. And WebTransport is this upper container. For deployment, right now it's fully supported by Chrome for the last 2 years, Mozilla Firefox for the last year, and as of 2 months ago, Safari behind a flag. So we expect it to go to mainstream Safari. So we have all 3 major code bases deploying it today. Now, why do we care? So if you work in the world of highly scalable media, we have something called adaptive HTTP streaming, which is HLS and Dash, right? It's non-real-time delivery. We have an encoder producing a bit stream. Our packager cuts it into little objects, which we basically give names and we stick in a flat file system. So we lose the order. And then we create a text file, a manifest or a playlist, that describes the order. So when I want to play this content on the other side of my virtual wall, I have to send my text file to the player, and the player reads it, and then it knows how to request these segments in the right order, and it can basically feed it into the decoder. But wouldn't it be cooler if we could not do that and just send our media straight through? So if you're in a broadcast world, or if you're using WebRTC, this is essentially what you do. But we're talking about upgrading very highly scalable distribution, millions of concurrent users, to use a solution more like this. This is basically a pub-sub network. Instead of asking for a little object every half a second or a second and doing that, I just want to ask for my video, and for the next hour, I want you to send it to me. So Clearly, it's nice, but why hasn't it worked at scale? And there's a number of reasons for this. One is that it was never designed for distribution via CDNs. Like, I work for a global CDN. We have 4,000 POPs around the world. That's our differentiation. We don't have WebRTC on those POPs. It's live edge only, so typically the systems today you couldn't rewind, or more importantly, you couldn't consume it at a slight distance behind live to be able to trade off latency for quality. They were either focused on contribution, like SRT on the one side, but we don't use it on the distribution side. There's not this uniform transport we can use across contribution and distribution. And also a lot of proprietary solutions. There's never been a global standard that we can rely upon, as there is for HTTP, and also tight binding of codecs and media formats. So, pub/sub systems are very nice for the internet, but they have to solve these problems here if we want them to work at scale. So a number of things are then coming along. I mentioned we've got WebTransport, we've got QUIC now, it's the basis for HTTP3. We're interested in going back, essentially, and recovering pub/sub for live. We want tunable latency, and we've got some things we can do with congestion controllers. So these are all ingredients, and we're baking a cake, is the analogy, and that cake we're baking is called MOQ. Now, I say the name MOQ, it started off meaning media over QUIC, right? But there's many applications which are not media-based. And in fact, MOQ, all the demos I'm going to show you are not running over raw QUIC, they're mostly running over WebTransport. So the name's a little confining. So people say, well, let's call it many things over QUIC to preserve the acronym. They're like, no, we're not going to do that. So at the last IETF meeting, we're trying to make it, I'm one of the people who agree with this, that it's just a name. So if you read the QUIC spec, QUIC doesn't stand for anything. It's just a name. I want MOQ to also not stand for anything. So think of it as an umbrella term for a family of related specifications. And one of them, the core one, is this one, MOQT, which is MOQ transport. This is built by the IETF. We're working on it right now. There's a big meeting next week, I'll tell you about it, and it's the underpinning. It is how we move data in a pub/sub network over QUIC or WebTransport. But there's a bunch of other specs that make this one useful, right? Low overhead container, how do I package video and move it over here? Warp, a streaming format, basically how do I stream in a commercial sense? CAT for MOQ, how do I add token access and authentication and control to this system? So all of these are currently being worked on at the same time, and I put them under this umbrella of MOQ or MOQ, depending how you prefer to announce it. So what is MOQ transport? It's a transport for moving binary objects, not only video. You can move database objects, you can move camera controls, you can move drone controls. It doesn't care what's the payload of the object you're moving. It's pub/sub, meaning I publish data and I subscribe data into a network of interconnected nodes. It's cache-friendly, meaning we cache whatever is moving through it, and you can go back and ask for it later. It also has tunable latency. So we're designing it for real-time communications. This is the world of WebRTC, sub, say, 200 to 400 milliseconds target latency. Also interactive live, which is a very interesting area for live sports, betting, gaming, gambling. And then what I call conservative live, which is considered low latency for most of the streaming at scale industry today. It can also do VOD. VOD just means my cache is big enough to hold stuff that was previously live a long time ago. So I can use the same distribution network across all these latency regimes. What's the status? Work, the repo began 2023, and since then we've had a number of draft updates, and there's been a lot of them. So the last one was released just earlier this month. We're on draft 14. The chairs put out a goal of basically completing MOQ transport midway through 2026, which is next year. So this is not a product you can buy or sell today, but there's an awful lot of development going on in parallel to the spec. So the oscillations in the spec, the changes, the wireline changes, are being reduced with each draft that comes out. It's a very active group, it's very open, anyone can participate in this, assuming you have time to kill and an interest. So, the MOQ ecosystem. MOQ is built on raw QUIC. When I say raw, it's just a quick connection between a client and a server. WebTransport is a thin layer of HTTP that sits on top of QUIC. That's all it is. And it's not the full HTTP stack either. It's just essentially the initial connection. But it's very useful because it looks like you're connecting to an HTTP3 resource from the outside, and then it upgrades itself to WebTransport, and then it essentially gives you the QUIC connection, and then HTTP is gone, and now I'm just have my QUIC streams and my QUIC datagrams. MOQ transport then is the protocol sitting on top of this. On top of MOQ transport, we have what we call streaming formats. So if you think of an analogy on the internet, this would be HTTP running on top of either QUIC or TCP. And then I have streaming formats like HLS or Dash, and there's many of them, right? There's no limit to the number of streaming formats that can use transport. And Warp is one of these, low overhead container is another one, but we could have a chat system if I just want to send messages, also operating. And the decoupling here is that we want CDNs to deploy this at scale and globally as a service, right? And then I can bring my applications, and many of them, and I can plug it in and just use it. Much like we use HTTP CDNs today, and I plug in all sorts of applications on top of them. So the object model is very simple. We have a concept of an item called a track. It's hard to read the red here, sorry. It says a track is a sequence of groups. Groups are abstract, they're not physical differentiation. Each group is comprised of a sequence of objects, right? And these objects should not be dependent on objects in other groups. So when I'm mapping media, a group is essentially a GOP, and my objects are frames within that GOP. Because as long as I have that group, I can decode all the objects within it. And the object then is the lowest level. It's the addressable unit inside MOQ. As you might think, it's got some headers and it's got a payload, and that's it. And we don't care what the payload is. And this is very agnostic, right? This object model doesn't indicate that you must use audio video here. The messages in MOQ, so MOQ is moving messages. These messages are objects. So the objects can be either the payload that you're moving or control objects. They are set up in a special bidirectional stream, and there's a message type and a message payload. And here's a list. I'm not going to go into all of these. You can read the spec today. But if you're familiar with pub subsystems, you subscribe, you publish, you announce, you do setup handshakes. It's not that complex. Subgroups are interesting. And again, there's too much text on this slide, but normally if I have a quick stream, my challenge always becomes how do I map MOQ objects to my actual transport layer? And I've got these individual streams. Do I put everything in the same stream or not? So if I have a quick stream, I can put my group, which will be a keyframe and then some groups of video, and this might be my GOP. And I put that in one quick stream and I put it in another. That's one way to map it, right? But what I might want to do is set up two quick streams in parallel. And I would want to do this because I can shard my objects. I can put my first frame here, my second frame here, my third and my fourth. For example, if I have 30 frame per second video, I can put a 15 frame per second layer here and another 15 frame per second additive layer here. The advantage is, and I keep doing that, the advantage is if I get packet loss here, I can discard this and my decoder can just do 15 frames per second for a short period of time and then recover later on and go back to 30. So if I'm doing real-time media, it's much preferable to be able to drop some data than to go back and retransmit it. So when you hear about subgroups in MOQ, they're really just, everything in the same subgroup should be in the same quick stream. That's all it is. And if you don't want to use subgroups, you don't have to. We address content via a combination of namespace plus name. So I might want to call my track video, right? But clearly it's going to conflict with other people also calling their track video. So a namespace is literally the namespace in which my name is unique across the distribution network. And the combination of namespace, name, group ID, and object ID uniquely identifies every object in a MOQ distribution. And we can use text for this. The domain here is not a DNS mapping name. It's just saying I own this domain and I'm going to start my prefix with it. But the names themselves, namespace and name, are binary. Namespace is a 32 field tuple. So we have 32 fields. I can allocate what I want. I can just use one. and I'm very flexible. Most of us, in the examples, I'll use strings, but we're just converting those strings to binary when it actually gets on the network. So how do you get new objects? It's very simple. Imagine I have a flow of video. So here's my GOP. I got a keyframe at the dark colored ones. It's going forward. And we're observing it at this point in time, right here. Those are in the future. These are in the past. So I can subscribe to it as what's called next group start, where the relay will then send me the next group boundary that it sees, which would be the green ones, 3.0. I can describe it the latest object. And since I'm midway through this object, it doesn't count. The next object would be 2.3, and then I get everything else in the future. I can do an absolute start, say, I want to wait. When 4.0 arrives, send it to me. Same thing, the relay can do that. And I can do an absolute range from 3 to 4. So those subscribing is for fetching objects in the future. And it's an interesting separation. So how do I get objects from the past with MOQ? I have a different verb or action called fetch. This is not the fetch we use in JavaScript, although its name is very similar. There's an API for it, but basically you can anticipate that, hey, I want the namespace, I want the name, I want my start group and my end group. And I can go back and fetch it from the relay. The relay will pull it from its cache. If it doesn't have it in the cache, it goes back to the origin publisher and pulls it from there. We have a thing called a joining fetch, which is a little more complex. It's where I want to stitch together stuff in the future with stuff in the past. And you might say, why do I want to do that? But that's actually the normal joining case for segmented media. I want to join a stream at the last keyframe that was sent out. So I want to go back a little bit in time to the last keyframe. So what I do is I subscribe to the future, and then I say, by the way, make me a fetch that starts at the last keyframe and attaches itself to the front of that subscription, and do that for me. So I get seamless video, and I don't get competition on the wire between my fetch and my subscribe response. Now you might say, I just care about live video. What are the use cases for fetching anything, right? So one of them is DVR windows. In sports, when we want to go back. So I have a hypothetical sports game. We have this rolling window that follows the live playhead where you're allowed to scrub back in time. So in this concept, the user might want to start at this point, and then they would just issue these fetches of these groups forward. The playhead is up on the right there. I might want to retrieve subclips, for example. So here's a game. It's so hard to read. It says goal. There was a goal scored there. There's a penalty scored here. And I might want to come and just fetch my content for this range. This use case is going to be demonstrated on tomorrow's session in the afternoon by Ali, who's sitting in the front. They have a working version doing exactly this, which is be quite nice to see. And you can still have your DVR window at the same time. You can even play a VOD asset. We can play Big Buck Bunny, right? And all we're doing there is just fetching content from the beginning. It's content that actually was never live to begin with. And if we want to seek forward, all we do is fetch a different range. So it's quite simple to apply that to VOD delivery. And we can also fetch backwards and set a filter on the keyframes. And you might say, why do I want to do that? But that's your scrubbing mechanism. So when you have a long 2-hour movie and you want to go backwards or forwards, we can just tell the relay, just send me the keyframes in either ascending or descending order, and it'll do it. And we get our keyframe generation for free, essentially, for our scrubbing interface. The other one, if you just say, I just care about live, but I want to monetize it. The other way, if I have a live stream and I want to insert interstitial advertising content, then those ads are essentially VOD. They were prepared but encoded before, and I want to inject them into my live stream. So even if you're just doing live, you still want to look at fetching to get your advertising support into your live streams. And we can do ads into extremely low latency live streams, as long as the ad is signaled ahead of time and the content is fetched ahead of time. So this just simple diagram, I mentioned we had a joining fetch. One of the reasons for that is I remove one RTT. So we have a race, we have a standalone fetch here. So that one is already started because it was able to do the subscribe and the fetch together, which is essentially a joining fetch. This one took longer because I had to get the answer back here before it could do a clean fetch. So we're able to start decoding and playing content within one RTT from request time. This is actually a very interesting feature of MOQ. It's called subscribe but don't forward. So let me explain what that means. I've got an origin, that's my original publisher, and I got 2 relays here and a client. This is a typical distribution system. And I'm playing multi-bitrate content. So I got tracks at different quality levels. And one problem with this in HLS or Dash is I might ask my relay for a quality level, but it's not available at the edge, right? The edge has to go all the way back to the origin, which might be in another continent, and fetch it. So now what we do, the client subscribes to the relay. The relay then makes a subscription to this relay, which makes one back to the origin, and the data flows back. And it says, I set a flag called forward. So I want you to actually forward me this data. At the same time, it does a subscribe, but it says don't forward for 2 other bit rates. And it's basically just warming them at the cache. These are being pulled, and they're active here, but they're not being delivered. So now when I want to do multi-bit rate switching, I can do it very quickly. I just turn off the forward flag and turn it on for another bit rate. And same for that if I want to switch down. So I don't need to make that trip to the origin. So I think this is a very interesting feature of MOQ that will certainly lower the level at which we can do multi-bit rate switching. Auth tokens are necessary. The internet is a lovely place to commit crime. And this is going to be a very accessible network. So we want to protect many things. We want to protect access to the network, but we also want to protect what you can do on it when you connect. So maybe you're allowed to connect and you can only subscribe but not publish, right? So we have a lot of, these are all the actions you can take. And we've created a generic token system that can supply encrypted tokens that constrain this behavior. This is the core transport. It doesn't tell you how to make these tokens. So there's another spec I'm actually one of the authors of called CAT for MOQ. CAT stands for Common Access Token. And it takes all the actions here, and for each one of these, we can constrain it by claims against all of these fields. So you can say, if you're in Krakow and it's between 8 p.m. at night, and you've got a token from your issuer, and you've got Depop, then you can subscribe. So very fine-grained control over the actions you can take on a MOQ transport network. This just got accepted by the work group, so this will also be published as a working solution. I think someone else is doing a JWT-based solution for this. This is a binary one, uses CBOR. Warp is the streaming format. So it's a lot like HLS or Dash. It says, how do I take content and package it? We have a thing called a catalog. So you ask the publisher for a catalog, and just like a playlist or manifest, the catalog says, oh, I've got 5 streams available, 3 video streams. These are the codecs, the bitrate, the frame rate, and some audio streams, and this is the channel configuration. And then the player subscribes to what it wants. We're publishing this right now. This supports a container format called low overhead container. It's a very lightweight container for moving audio and video. We have another draft called Carp. It's a terrible name, it's a fish, but it's just a CMAF version of Warp. And that's the one, there's a lot of CMAF-based content in the industry today, and I can take content from HLS or Dash and just repackage it for MOQ transport. A reminder, and I said it at the beginning, MOQ is not just for media. So we have use cases, autonomous driving, smart cities, industrial IoT. This is Huawei, China Unicom, there's open letters saying, hey, we really want to use MOQ for collecting and moving data. So there's a lot of focus on the video side, but I really do believe there's applications outside of that make it useful. So I want to start just ending with a whole bunch of pre-recorded demos, right? Just to give you a taste of what people are working on at the time. There's an open source project called mocktail.dev. Ali Begin is one of the maintainers of this. It's got publisher, subscriber, relay components. And this is myself testing it. So like all things we already see, you wave at the camera an awful lot of your life. You put up time code, but it's working nicely. There's another one called Mock Live Mock. So when we're testing things, it's very hard to keep a real live encoder running reliably for months on end, right? So this is a publisher that actually has VOD content, and when you ask it for a live stream, it synthesizes a live stream for you, makes it look like live, but it's actually based on VOD, which is a very useful tool as we build it out. He's written a player. This player is running inside Chrome. So he's going to basically connect what looks like a HTTP3 URL, right? That's going to establish his web transport connection. He connected, he got the catalog, and the catalog says, oh, you've got 3 video bit rates. He chooses one of them. He's manually selecting this. A player would automate the selection, right? This is a debug and dev tool. You can go and set the buffer you want and the latency you want, target latency 300 milliseconds, and then your video starts playing. And it's a special video where it's got the time code baked in, so you can do a bunch of testing. This is built by Torben out of Ivin in Sweden. Next, this was a player I built to test multi-relay routing, right? So we're going to have networks of relays, and we want to test how we can forward content. So I was in Denver when I recorded this. I'm sending my request to a relay server hosted on Akamai in Los Angeles. We're then reflecting it to another relay server in Madrid, and then I'm subscribing back from it. So these are the actual RTTs measured. That's my total RTT. Obviously, half of that is my one-way packet transmission. And this is, I wouldn't obviously go in a circle like this in the real world, but if I want to go from Australia to Europe, yes, I would be running through multiple relays. Again, running in Chrome, simple test player. So I'm just publishing this time code there. This is tracing out the latency that we have. And it's equivalent to what you would get with WebRTC. But the nice thing is it's highly predictable. So I have my 173 millisecond, half of my round trip time for distribution delay. I've got 33 millisecond, 1 frame encode, 1 frame decode delay, and then I've got my 40 millisecond jitter buffer. And we see that the sum of those nicely predicts my actual latency that I'm seeing on the network. So we're able to remove any delay. The relays are doing a good job in getting something and handing it out as quickly as possible. Vindrel, another Nordic company, they offer a live streaming solution. They basically use WebSockets and then custom encoding to distribute their content. They're now building an ingress to take all these different formats, RTP, SDI, MPEG, TS, RTSP, convert them all to MOQ and bring them down to their live engine. They also have that's on the contribution side, right? Now they are building a client that can also continue that MOQ out for distribution. This is another web page they built. It's a demo. It's a much more sophisticated demo than mine. So they're using WebTransport to connect. Basically here it's a multi-bitrate player. They can go in and choose 4K. The great thing with MOQ is your codecs are completely decoupled from your transport. You can put whatever codec you want in there. They can adjust the latency, 600 milliseconds, and they're just confirming that they're using MOQ for distribution. So they're a company now. They own the encoder, the relays, and the client. So they just pick one of those draft versions I mentioned and deployed it. And that's why they can deploy ahead of time. But if we're working on the IETF standard, we still got to wait for it to be complete. Live sports test. So I'm in Zurich. I'm publishing 1080p, 30 FPS, 5 megabits per second. I'm going to publish to Los Angeles, which I wouldn't normally do, but it's a good test. And then subscribe back again for the round trip. So this is just using OBS with some time code as my actual media source on the machine. And then I'm going to publish to a web page. This is using a library, open source library from Meta called Moxygen. And it's the client written by Jordi in Barcelona. So I'm just taking this feed and encoding it using web codecs in the browser and then publishing it with WebTransport and MOQ transport to the relay. And then I'm going to have another page where I subscribe back to that, right? And my poor laptop is trying to do all of this and encode it as screen capture, so there was that blip. But there's my latencies. You can't really see them, so I took a screenshot. We have our 1 frame delay between OBS and web codecs doing the encoding. And here we had 636 milliseconds from the codec, go to Los Angeles, come back. But there's a player buffer of 400 milliseconds that's intentionally introduced there. So overall, around about 700 milliseconds source to subscriber. I wouldn't run a live service at that latency. You don't need to. I'd rather add, say, go to a second or a second and a half, add a little bit more buffer protection on the client, and some ability, some time in which to do multi-bitrate switching. This is another implementation, one of the first ones I've seen of that fetch behavior. I'm not going to show it to you working. It's the session tomorrow here, and they will be demoing that player and its capabilities. So I think it's exciting to see. Cisco, if you know them, with the WebEx conferencing client, they're very interested in MOQ. They're building out their next generation conference client to use MOQ. So we did a test. We mounted it on an Akamai server in New Jersey, and then we tested from Europe, Seattle, and Santa Clara. So this looks completely uninspiring because we all sit in front of this all day, but this is 1080p video, and we're chatting, and we're actually doing tests to see how quickly the audio comes in. We don't want to clip the start of somebody speaking. So it's a test of how quickly you can initiate a subscription to a new stream. But that's not what's interesting to me, because this is what we have today. We then just switched the codec and the bitrate that we're using in that same tool. And this was my 32-inch monitor, 34-inch monitor that I'm now getting full screen 4K video conferencing on. And this, I think, is exciting because the quality here is a big step up from what we typically deliver it today. So you can imagine a corporate network where you've got the bandwidth to chat like this. We can now have the option to really increase the quality. I want to give a recognition to Cloudflare. They're a competitor of my company, but they just rolled out first MOQ deployment on 300 servers around the world. It's compliant with draft 7, though, which is one of the drafts from last year. But they've got it working. I'm doing hand-waving latency tests. It was 368 milliseconds. And I think that's not bad for a proof of concept that's rolled out. What are we doing on the Akamai side? Just last week, I launched an initiative called OpenMOQ. So OpenMOQ is a software development consortium that wants to create highly performant open source MOQ software for both contribution side, for the relay, and for the players. And these companies have expressed interest in being the founding members. We haven't signed the agreements yet, but they're going to. This is a competitor of ours, so we're actually collaborating in order to build common software. Cisco for WebEx, Oracle, very big company, Cinemedia here in Europe, and also YouTube. YouTube care about the contribution side of this. So if you're interested in this project, there's a URL and there's a QR code. Or just come talk to me. I'd be very happy to get you on board. The ITF is very open. Next week in Toronto, there's a hybrid interim. You can join online. You can watch the sausage being made in all its glory, but there's a number of key issues, and you can see everyone discussing them and making this a good format. And there's another QR code for some participation there. So I'm a big enthusiast of MOQ. It's not the answer to everything. It has issues, but it also has a large community of engineers who are trying to make it better. And for that, I thank you. Cheers.